Welcome everyone, and good morning everyone, and welcome to Developing Cloud Native Worry-Free Applications in Azure. My name is Alex Mang, and I will be your host for the next 20 minutes or so. I'm a passionate Azure MVP and also Microsoft Regional Director, whatever that means, because I do not work for Microsoft, I do not own a region, and I do not direct anything. But yeah, that's the title. Cloud Native Applications, quite a mouthful, and a marketing term if you ask me. When you think about Cloud Native Applications, 20 pounds ago, when I started using Azure, that was literally when Azure was a brand new thing, we would just deploy our applications in Azure. And we somehow had this belief and this construct that if it runs in the cloud, it should be good. It's better than on-premises. But it isn't like that. In fact, Brandon Burns, who's a distinguished engineer at Microsoft, he likes to think of cloud native as this construct of two principal characteristics. One of them being API-driven, effectively meaning that you have APIs rather than opening up a support ticket to self-service yourself. Do you need a resource? Do you need to scale out the resource? Do you need to delete a resource? Everything is at the hand of effectively clicking a button for a REST API, and that's it. And I like that idea because it has to be like that. And then the second characteristics of a cloud native applications is this notion of elasticity and fundability. Now, elasticity effectively means that whenever you require more underlying capacity, it just scales out, or when you no longer require it, it scales back in, and you only pay for the actual consumption. And fundability means that there is no engineer walking around with an additional memory because you need more memory, or an additional hard drive because you need more hard drive. But I would like to add to that. As a software developer, I believe that cloud-native applications should be more than just about the infrastructure of cloud-native. And when you think about applications, in my opinion, they have to be worry-free, maintenance-free, any scale capable, highly available, and fault tolerant. And those are a lot of characteristics. But the idea is that if you figure this out, you literally have applications which run better in the cloud because the infrastructure which Brandon is talking about can actually be delivered by this thing. Now, the reality, when you come to think about it, is that if you do have that kind of application, you also have what I like to call peace of mind as a service. And the reality is that with Azure, the kind of services that you can put together to get to that point are a lot. Whether you use Azure Kubernetes services, Service Fabric, or use Docker containers, whether you use Logic Apps or functions or Event Grid, there are a lot of these applications. It doesn't have to be either one or the other. And coming to think about it, I actually want to show you in my first demo what serverless is all about. So this idea and notion of serverless in this demo actually starts with the scaling capacity of Azure. I need more resources right now, so how do I get those more resources? And what I will show you is over here in one of these resource groups, I have a scaling application called Scaling V2, which is just a super basic function application. If you've used function before, you've definitely seen one of these. It has a couple of functions. One is an HTTP triggered function. The other one is a service bus triggered function. Well, come on, Internet. Any moment now, it should show up. And the idea is that it just hangs around, and whenever there's an HTTP request coming through, it will answer to the request, responding to the request, telling it, hey, here's your response. Now, it's not very complex. Actually, this is a super boring, simple function application, just like the sample gives you when you do your getting started. But here's the catch. Any function can actually be hooked together and associated to an application inside. And that's a pretty cool feature of Azure because they will show you real-time telemetry data with a functionality which they call Live Metric Stream, where they will show you how your application is running in near real-time performance. And that's pretty interesting. Now, I have only one server, and I do have that one server not processing any requests right now, and the reason behind it is that I was actually looking at the code. So they spun up a server, they allowed me to edit my code if I would have required that, compile the code if necessary, and then just hang it around. Now over here, I have another application. This is called Loader.io. This comes from SandGrid, so this is not a Microsoft product. What this allows me to do is do a cloud load test application. And I usually use this because it invokes virtual agents which simulate user activity on my web application. So what I want to show you with this is that if I go here and just edit my standard cloud load testing application, I'm going to start from 500 clients and go down for 2 minutes up to 4,000 clients, just testing my application over and over again. And I want to see how good the scalability of this application is. So if I run this test right now, click the Run Test button, it will show me in a diagram how my response is at, how many clients I have on my application running at one point in time. And this is actually a very simple to use application, a very simple to use configuration tool, which allows you to do all of those tests. So the green line right here shows you the number of clients you have at a given point in time. It starts from, obviously, from 0, starts from 500 afterwards, and then goes gradually up to 4,000 as I requested it. The average response time I'm getting is shown by this blue line instead. So there is a bit of a cold start here because I'm using the cheapest and the most price-effective, let's say, functionality and SKU in Azure Functions, and then we see that it kind of averages out at around 500 milliseconds. So that's a reasonable web application, considering that I'm not paying literally any single cent when the application isn't used. But if I go back to my live metrics stream, you're going to see that my application is being served by 25 servers, 26 servers, 27 servers. And the number keeps on going over and over and over and higher, so that all of those customers that are trying to hit my application get all the responses that they're looking for. And that's pretty interesting, because if you look at the number of requests which are coming through, well, which are over here actually, you're going to see that those requests are just keep on increasing, and my underlying performance is handling all of those requests. How many failures do I have? 0. Now that's pretty intense and pretty cool. Now if I go back to the client side, I can tell that I actually have 0 errors from the network as well. So no 400s, no 500s, nothing happening on the client side, nothing happening on the server side. It's all cool. What do I pay for it? Well, every single execution, and that's it. If I don't use it, no problem, you don't pay for it either. Now, the scalability of an Azure function is the cool stuff. But the reality is that when you start talking about cloud nativeness, event-driven applications are not a one solution fits it all. Just think of it like that. Not everything can be replaced by fire and forget kind of approaches, which event functions is, Azure Functions is. Azure Function does indeed have a capability called durable functions, and also another capability which allows you to write actors called durable entities, which is under preview, but is already production ready. Now, here's the catch with that. When you talk about cloud native, a lot of people invoke the concept of Kubernetes, how you should use Kubernetes, and I agree with that. Kubernetes is an amazing orchestrator for orchestrating containers. But when you're a software developer like myself, thinking about concepts such as replica sets, deployment sets, stateful sets, daemon sets, deployments, services, ingress, networks, and so on and so forth, just to represent how your application should work, when your application is a single representation as a pod, makes you realize that you're actually thinking about your application in more terms of infrastructure rather than the application design or the application architecture. So whilst this is an interesting tool to use, it actually puts you a bit down, because there is a very steep learning curve when it comes to deploying your application to Azure and start using it. There is an alternative to it, which Azure has in the form of Azure Service Fabric Mesh. Now, Azure Service Fabric Mesh effectively is a capability where Azure manages the orchestrator, manages the runtime of the application that you required, and you have a single representation of the entire application rather than the individual components, which we commonly call microservices. So if you were to look at how this actually looks, you're going to see that over here in Visual Studio Code, there we have it. There you are. In Visual Studio Code, you have a ARM representation, so an ARM template, which shows you the entire representation of your application under the form of, let's go right here, under the form of services. So the service is a microservice. Isn't what you know from Kubernetes as a service. It's a microservice, part of my application. The application just so happens actually to be the entire representation of these properties. If you go further up, you're going to see here that I have another ARM resource, which is a Microsoft Service Fabric Mesh application. So why is this important? Because when you deploy this ARM template, what you're actually deploying is a single resource which represents your application. And if you have n microservices, and those have to communicate, maybe you have API gateways, maybe you have things like that, they communicate with their own private network. How is the network represented? Well, it's not an Azure virtual network. It's actually a network representation as a software-defined network instead, further down here in my ARM representation. So if I were to actually to go in the Azure portal, and I will do that right now, go back here and search for my demo serfab. There we go. You'll see that in my resource group, I have only my Azure Container Registry and my Service Fabric Mesh, which represents my application. So when I want to deploy something, I just deploy my own containers, container images effectively, to the container registry, which makes my container work, my application work, no matter how many applications you have. You want to configure ports, you want to configure API gateways, facades, service meshes, or anything else. No problem, it's still going to be a single construct, which simplifies the infrastructure side for a soft developer a lot. But unless you've been living under a rock here at Ignite, you probably have heard that they are announcing and putting a lot of emphasis these days on another service called Dapper. Now, Dapper stands for Distributed Application Runtime. And it effectively is taking the Service Fabric Mesh application model and allows you to write Dapper microservices for any application whatsoever. It's all about distributed applications at the end of the day. So the reality is that there are a lot of distributed applications already, and there are a lot of runtimes that you can use already. Why would you use Dapper? Well, think of it like this. Dapper runs alongside your application. It is not injected in your application, doesn't take over your application, and you don't have to write any kind of boilerplate code. No infrastructure code in your application code. Now, Dapper does several capabilities. It does service discovery, it does pub/sub, it does service mesh, it does state management, and all of these. But you don't have to use all of them if you don't want to. If you already have a framework that you're using right now, it's up to you to actually use those frameworks, such as Spring Boot. Are you using Spring Boot? No problem. You can use Spring Boot and inject it with Dapper, because the way Dapper communicates is over HTTP and gRPC, which means that any language that you would pick, and actually I have a cool diagram for that one as well, is going to be able, as long as you have an HTTP client in that particular programming language, is going to be capable to communicate with the Dapper runtime. So Dapper runs as a side container and allows you to have all of these capabilities: service-to-service invocation, state management, publisher-subscriber, resource binding and triggers, actors, and all of them again. Now, here's the catch with that. When you look at one of these applications which are written for Dapper, and I will show you my first application, which is in Node.js. Let me take you to it over here. You will see that, oh, this is a bit too large. So over here, I have a Dapper-enabled application. Come on, there we go. Just gonna get some screen of state back. And in this application, what I'm using is that I'm just invoking Express and body parsers, some very typical libraries and packages for my Node.js application. And whenever I get an order request coming in my application, I'm effectively going to go further and ask for the state of that particular order. So I want to post something such as order ID 1. I'm going to get further back with the order ID 1 when I call this API over here with a get HTTP verb. I want to post an order, no problem. I'll have a new order which will say, hey, take me the data from the request body of my HTTP request, post that information, and store it in state. Did I write any state-specific boilerplate code in my app? I didn't. I'm communicating over HTTP with something, and that something happens to be Dapper. In fact, if you look over here, my files for my Dapper, you'll see that there is literally no special JS file, TS file, or anything like that doing the Dapper stuff. It just happens to run, in this case as a container, but can run as an exe file if you want to, and which is defined right here in my Redis YAML file, for example, or in my Redis message bus file. If you take a look at it, it does look like Kubernetes, because they're taking the same language syntaxing, but it is not a Kubernetes object, which effectively means that your application can run in app services, it can run as an Azure container instance, it can run on premises, it can run literally anywhere without you being required to learn Kubernetes. Is your DevOps you already using Kubernetes? No problem. You can use Kubernetes, but not worry about the fact that they may only deploy a number of pods and then configure the additional services or whatnot, place labels and make your application not work. Because that's a very typical scenario, unfortunately, for Kubernetes environments, for Kubernetes-heavy companies. So the way this guy works is that if I just open up one of these sample applications that I have over here, let me first open up actually the terminal. And in the terminal, I will say that I want to run Dapper, hit enter. I'm starting now my Dapper communication. There we go. And let's, for example, post a new order right here, send the request. And I'll get the response back which says, okay, we took your order. So now if I want to read my order, which is further down here, send the request, I'm going to get back my order, which was saved right here, order 32. Or 33. That's very good. Okay, so the idea with Dapper, if you think about it like in the form of a diagram, let me show you how that was put together over here, is that my application, my node code right here, was communicating with the runtime, and the runtime, whatever you want to use, whether that's Redis, whether it's Cosmos DB, or whether it's an Azure storage account, or PostgreSQL, whatever you'd have, would make sure that this communication with the underlying technology is being taken care of. So you don't have to write any kind of client code, you don't have to write any kind of injection over here in Node.js app. Instead, you rely on Dapper to do the communication with that. Now, going further than that, if you're an ASP.NET application company, that you can use another scenario, which I've put together in the form of this application right here. There we go. Let me zoom out a bit, because this may be a bit long. And in this application, I have effectively an ASP.NET app with a client and a service right here, and a bunch of interfaces which are just being shared across. So what I'm trying to prove here is not state management, but actor implementation. So in this application, my actor service effectively has a controller called the weather forecast controller. And in my weather forecast controller, I'm effectively going to be able to query, save data, return data, and so on and so forth. So you want me to store, for example, the weather for a particular city, or for the weather for a particular anything else? No problem. My stateful application will no longer have to be written and taken care of inside my app. Instead, I'm going to write a actor, and this actor will have all the contracts with all the events and communication which it is capable of doing. And then my application written in a client, in my actor client, will be able to query this actor and return all the data back. So the way this works is that over here in my client, in my program CS application, I'm just invoking any of the actors I want to work with. So how do I know how to invoke an actor? The actor per se, this actor ID, for example, is a representation that I've written directly in my interface. In my interface right here, in my iActor CS, I'm specifying what capabilities does my actor have. So for example, I can register a reminder, remind me about this forecast in that particular city, unregister a reminder, register another timer to remind me on a regular basis every now and then what exactly the forecast would be for that city, and so on and so forth. And the data that I'm looking for could be a property like the city, the temperature, and other things like that. So the idea is that in my client, I would query the actor per se for every single reminding I would like to get back. And in my service, I just have a completely stateless service that calls an API, and it knows that this actor has a context for whatever was set up. So I, Alex, for example, I'm interested what the weather will be in Orlando. I'm going to set up a new actor, and that actor will run by itself. Now, the beauty here is that I don't have to write any of that boilerplate code to make sure that they always have an instance running, that they always scale up an instance, or anything like that. And instead, I'm relying on Dapper to make sure that that state is persisted, and the state can be queried, and the communication from a client towards an actor can take place. So all the boilerplate code, again, is being taken care of for me. Now, what exactly, or how does exactly this help me? At the end of the day, when you think about cloud-native applications, you got to think about this a concept of a worry-free application, of a maintenance-free application. I would ask you, how much do you want to control the infrastructure? Are you one of these companies who want to control network communication, who want to control service discovery, and things like that? Maybe Kubernetes is a good option for you. But if you're not ready to go further with the steep learning curve Kubernetes has, I would actually suggest to wonder yourself, do you really need what I call polynimbus, multiple clouds? Do you really need to go in the container world in the first place? Do you really need to make sure that your application can run both in AWS and in Azure and the Google Cloud Platform on premises at the same time? Because if you don't, the abstraction that containerization brings can actually be brought to you by Dapper at the same time. And in those terms, the last thing, and most importantly, would be think of your cloud design patterns. Microsoft on the Microsoft Docs has an amazing article called the Microsoft Cloud Patterns and Practices, which effectively allow you to learn and to implement all those performance, security, networking, communication patterns, even microservices, distributed application-specific patterns right inside your application. By doing so, you're going to make sure that you have an amazing app. At the end of the day, I don't think it's all about Kubernetes these days. I think that in 10 years probably from now, our entire story about how software development works will be less about the language, less about the technology, and more about the building blocks. Think of it like Legos, which you will integrate together and eventually have digital twins, have virtual actors, have things like that that will allow you to literally mirror the real world. And by doing so, you'll be able to write code with more empathy, with more inclusion, with more diversity, and that will be the main focus of the software development, rather than picking the language or the technology or the framework. And with that, I thank you. Feedback is very much appreciated. If you want to have a conversation, I'm more than happy to have it afterwards.